Our next speaker is Reshma. She's from the Home Depot, and she serves as data science manager in the e-commerce division. And she's going to talk about paradigm shifts and enterprise concerns around LLMs, which I think is a really interesting topic. It's not just about the technology or the techniques, it's about change management. It's about how do you adopt these things, specifically more on the conversational AI side. And the term that she would like to use for herself with regards to where she fits into this ecosystem is fierce. So welcome, Reshma.
Thank you. Thank you. Before we get started, can we actually have a huge round of applause for the organizers and all the previous talks that we heard today? So I definitely want to begin with thanking the organizers first. This is my first time to the Southern Data Science Conference. Thank you specifically to Khalifa as well, who is my former colleague at Home Depot, who invited me to be here. And before I get started, hello everyone, I am Reshma, Data Science Manager supporting conversational AI initiatives within the Home Depot. And I'm here to talk about the paradigm shifts and some of the enterprise concerns around large language models. So, okay, let's see. Okay, working, perfect. So I think large language model, the buzz around generative AI has been there for quite some time now, especially with the launch of ChatGPT back in November 2022. And of course, within SDSC here too, we hear a lot of talks about LLMs as well. And here during the talk today, I am going to focus specifically around the text-to-text models. Generative AI as a broad term refers to a lot of language models. It could be text-to-text, text-to-image, the multimodality of it all. But because my area of expertise is in conversational AI, I'm going to specifically focus on the revolution around this specific space and how it affects building chatbots and conversational assistants in the future. So this is fundamentally how a conventional architecture of your chatbot or your virtual assistant used to look like. So you have the first component, which is your natural language understanding part, your NLU, and then once the bot is able to understand the customer questions, then you have your planning, where you have your dialog state tracker, your dialog management, policy planning. And once the bot is able to understand the customer's question as well as find out the context of the information, which we all know is very important for conversational AI, because it's not just about what the customer asks at a particular turn, but it's also about what they previously asked during the previous turns as well. So maintaining that context of the conversation falls into the planning realm. And once a bot understands this planning too, the next major component that comes into place is the responding, where you have the natural language generation and the response back to the user. And of course, in this overall architecture, let's say the virtual assistant that you're dealing with is voice-based, like Alexa or something. You will also have your text-to-speech and your speech-to-text component embedded in the front as well. And that's where your automated speech recognition component falls into place. So this is high-level overall how conventionally majority of the virtual assistants chatbots architecture used to look like. And from a use case point of view too, there are two areas that your virtual assistant can do. One is task-oriented and the second one is information-oriented. Task-oriented being, hey Alexa, switch on the light or something like that. So you ask your assistant to perform a particular task. So those are your task-oriented dialogues. And information-oriented is where you ask Alexa for the weather. So those are your information-oriented ones. And of course, this fundamental architecture has its own limitations. So for those who are in the space of conversational AI, you guys will definitely be aware of this problem. Because you have those multiple moving components that goes along with it, making change in one place also means that you could create that ripple effect of change in other modules too. So you need to be very careful when you're making changes within the system. And it, of course, requires expert to handle or create these assistants. And you also need a pretty good amount of label data too. Where this is changing right now is the end-to-end architecture, what we have in ChatGPT. So that entire component of natural language understanding, dialogue state tracking and planning, along with the response generation, all these components together are now embedded into one huge large language model, which we call as end-to-end conversations, end-to-end dialogues, similar to what ChatGPT does. And of course, here also, it's not perfect. There are certain limitations with this architecture as well. As we all know, handling information-oriented conversation becomes difficult because here, most of the LLMs are trained up to a particular point of time, and it can still hallucinate or generate or make up responses. So in industry use cases, it becomes a huge issue. It is difficult to perform error analysis, the second one. Of course, I mean, if the LLM is making something up, it's very hard to go back and do reverse engineering on exactly where things went wrong. So it becomes harder to find those errors. And of course, the whole fundamental concept of reinforcement learning with human feedback requires large amounts of annotated data. So it's not easy to build an LLM as well. Going into the next one, which is the most important and interesting paradigm shift that I feel was very interesting to me, starting from the first one, which was a change in architecture, is the reasoning, where the paper from Stanford on artificial general intelligence also speaks about it a little bit. So the main components around the chain of thought reasoning, zero-shot chain of thought, where right now we have algorithms that are basically capable of providing reasons along with generating responses, is a huge milestone by itself. We did not have that before, and this is where things are actually getting disruptive. So giving like a mathematical task, person A has something, person B has 4 apples, person B has 5 apples, and they both bought 7 apples. How many apples do they have? And you ask your LLM to generate a response with chain of thought. It will be able to provide a response along with an explanation of why it came up to that response. So it's a huge shift in the industry by itself. And of course, not just reasoning alone, in terms of action as well. Because as much as it's important to reason why the LLM came to a particular response, providing or doing actions corresponding to those reasoning is also important. Again, in industry use cases where you want to integrate with an API or external knowledge source. Again, recent papers around like Toolformer, React have fundamentally broken the internet and with the industry with all the amazing results that's going around with reasoning as well. The next interesting and most important paradigm shift that is also happening in the space is the change or generalization of the model architecture by itself. So first, in NLP ecosystem, we used to have specialized models. So we used to have like a specialized model for summarization, an algorithm for question answering, another algorithm for sentiment analysis, and so on. And now we have one huge monolith that's capable of handling all the tasks, and all you have to do is provide a simple prompt or maybe a few examples to do so. So which again is a pretty huge significant shift in our industry. And this brings us to an area where in conversational AI too, your data and your data efficiency plays a very crucial role. We used to start fundamentally, I guess, a decade back or so with conventionally pre-training your algorithm with hundreds and thousands of annotated data. And now in recent times, we have been doing a lot of fine-tuning. So we had algorithms that were trained on open source data set, like from Google or Wikipedia or Twitter, and all we had to do is fine tune it for a specific domain, and maybe even add an additional layer for your specific use case or your task. And voila, you'll have an amazing algorithm that specializes and has extremely good results with low number of annotated data. And now we are into the era of prompting, where all you need is just few examples, or even in a lot of cases, you don't even need examples with zero-shot learning. So after the paradigm shift, I definitely want to also call out some of the challenges too, because everything is not green and grass is not always green on the same side. So some of the biggest limitations that we had in the LLM revolution is, of course, I mean, a lot of people have talked about it, the hallucination and grounding the knowledge as well. So an example here, which team does Messi play for? If you ask an LLM like ChatGPT or something, it's gonna say it's PSG, but we all clearly know that he no longer plays for PSG. So RAG, as the previous speaker also spoke about, retrieval augmented generation is a very frequently researched upon area in the recent times, where you have a retriever along with your LLM to retrieve the most relevant knowledge for a user query and then generate a response. And at a high level, this is how your most retrieval augmented generation algorithms look like. So you have a user input, you have a retriever component in the middle that lets you search for relevant information, articles, and then it gets fed into the large language model, and it helps in generating a response for that. And from an architecture standpoint too, there are different moving pieces. Even though it sounds very simple in the previous slide, there are a multitude of things that you can do there. So first is looking at the type of retriever. What kind of retriever can we use? We can use something as simple as BM25 or TF-IDF. You can use dense retrievers, again, that can be trained. You can also have knowledge graphs that can be used as your retriever instead of having a conventional vector database kind of approach. The information could also be in your website or in the form of API. So these are all different areas in which the information could be stored. And in terms of the architecture too, if you look at the retriever and the large language model, they can either be trained together, and of course this is only possible if you are maybe using an LLM like Llama or something that's open source available. It cannot be done with like ChatGPT or Google Sparm or something like that. But let's say you have control over the LLM, training them together is an option. Or in other cases where LLM is black box, you can also train your retriever separately, or you can have like a frozen retriever, which is again fine-tuned or already trained, that can also be used for generation. And looking at the third component and how do you integrate these retrieve knowledge, one of the most simplest approach is putting it in the prompt, or it could be done in context as post decoder or fusion in decoder as well. The second other challenge that I definitely want to touch base here is the human AI content loop. The reason why this is important for us within the data science community is because we have a lot of use cases where we want to leverage large language models in production or customer facing. But there is also a lot of work that is going on in the realm to use these large language models for generating some kind of synthetic data or annotated data or labeled data. So what this means, what is really happening is you have your synthetic data generated from the LLM, you feed that into your algorithm, then that algorithm generates a response, and it basically creates this infinite loop where you don't really know whether the data actually was machine generated or it was created by a human. In computer vision task, it's fundamentally a little bit more easier because they have like watermarking and other techniques where you can encode and say that a particular image that is generated is from an algorithm and not from like a human captured image or something. Versus in the language space, it's a little bit more complex. And of course, there's a lot of research that's going on in this area too. So how do we differentiate whether something was generated by us as human or by an algorithm? And of course, it failed the Turing test too. I think humans were not able to understand the difference between generated language versus actual human language. That was also very interesting. The second, the third important challenge in the realm of conversational AI and virtual assistant is also personalization. Because as much as these LLMs are powerful, what customers have started expecting nowadays is they want an assistant that's tailored to their use case, or something that knows them well enough and provides a response and generates response accordingly. So let's say if I asked ChatGPT today saying, hey, I'm coming to STSC for, which is happening in Atlanta, suggest like a nice one-day itinerary for me. Of course, it's going to generate an amazing itinerary. You can start your day with going to some brunch place, and then you can check out the Coke Museum or the Georgia Aquarium and so on, and then you can finish the day going to Hattie B's or something like that. But let's say I'm a person who personally loves sushi. I would expect the LLM to learn from my user behavior and suggest things that I personally like that the assistant probably would have already known. So how do we incorporate that? How do we make the assistants more personalized? It's a huge problem, and we also need to make sure that it doesn't become a pigeonhole problem or having hyper-focused recommendation based on the customer too. Some of the other challenges in research areas, this is very open for anyone who is in the research community. I spoke to a lot of PhD students as well. So anyone who is doing research, definitely I think these are all areas where the community is working a lot, and I feel like there's still a lot of work that needs to be done. First is, of course, integrating knowledge from multiple sources. So when we looked at the RAG architecture prior to this as well, the information could be in different forms. It could be in a knowledge base, it could be in a website, or you would have to integrate the information from an API, or it could be in a knowledge graph. But what if there is a use case that requires everything or like multitude of things altogether? How do we build an assistant that's capable of juggling or toggling between those? So that's definitely an important challenge. Explainability is, of course, a pretty important research area as well. So I think within the research community, the gap between scaling versus explaining has grown apart significantly in the recent times. What we've been doing is we've been putting a lot of compute and throwing large amounts of data, where of course we are building extremely powerful algorithms, but going into the fundamental and explaining why is the algorithm working a particular way, why is it not working in a particular way, all those questions still lingers, and we do not have answers for those questions yet. And especially, of course, with large language models, it becomes an even bigger challenge. And the LLMs, again, going into the era of multimodality, including images, audios, videos, and everything. When we go into all that area, how do we even explain what is going on? So that is definitely a pretty important challenge in our area. The next one is continuous learning. So as I mentioned, again, I think it falls back on the personalization slide as well. So how do we make sure that the assistant is able to learn from the user behavior on things that it should do and shouldn't do based on how the user responded to their previous interactions? So that becomes extremely important. And memory management as well. So that is also another area that is very important and is a pressing challenge in this space. Other areas where there could still be potentially a lot of work that can be done is in terms of performance. How do we find out whether the model is leaking or not? What is the best ROI cost that is associated with a large language model? Because we all know, both in industry use cases as well as in academia, there is potentially a pretty big cost currently right now with integrating an LLM, be it in terms of compute or the data or the size that is required for putting something in production. So how do we justify the ROI? What use cases should we go after if you want to use such a technology for that particular use case? How do we make sure that the prompts are monitored? Prompts constantly have to be changed or updated along with the algorithm. How do we do that? Latency, of course, I saw a lot of talks today as well in terms of latency. So how do we reduce that? I mean, putting a lot of GPUs or TPUs probably is not the answer, but how do we efficiently make the latency low with these large language models? Again, a lot of people are doing research in that area. Transparency, bias, how do we make sure that these language models do not inherit the biases that we had on the internet? Even the paper, Artificial General Intelligence, Stanford also used to touch base a little bit around that too. So because these LLMs are trained on everything that we have on the internet, what is the bias that it learned? What kind of political ideologies do these LLMs share? And they also try to ask some examples such as orientation, like based on religion. If the LLM is changing the response based on these input, is it actually changing it? And surprisingly, yes, it did. So unfortunately, it's still learning those biases that we had in a society too. So how do we make sure that we are not doing those? And of course, A/B testing, how do we know the model doesn't change with different versions and when it's constantly in production? How do you measure that the safety of the generated responses too? So a lot of challenges, a lot of very interesting things that I think we can work together within the research community. And I would actually like to end my talk with an interesting quote that I came across, which is once a new technology rolls over you, if you're not part of the streamroller, you're part of the road. So I feel like as a community, especially because we're all here as data scientists together, it is important that we use the technology to benefit the entire human society together, because it's very powerful, no doubt on that. But also make sure that we have a responsibility in making sure that it's doing the right thing and we are generating the right kind of use cases, be it in industry or in academia too. So with that, feel free to reach out to me via LinkedIn or email if you guys have any questions or just want to discuss and brainstorm about LLM, which I would love to do. But thank you so much for your time. Appreciate it.
Thank you, Reshma. We do have time for one or two questions, Reshma, if you're willing to entertain them.
Yes.
Okay. Do we have a question for Reshma? Okay, going once. Oh, we got one. All right. There you go.
Actually, there's this particular technique known as LLM pruning, which basically modifies the already pre-trained weights. So, is that something which is currently being used in the industry to basically just modify the model so that the output that it basically produces is more not that biased, basically?
So I would say definitely a very interesting research area. And I think one of the speakers before me, or I think prior to that, mentioned about this. But in a lot of use cases, what I think generally we all have observed is just few shot learning or like zero shot learning have been enough. And of course, RAG also has done a pretty significant value in terms of understanding and giving that domain specific data. But if that particular for your use case, either be it in industry or research or academia, or wherever you're from, if it requires that level of adoption, then I would say go for it. But I would say start from something simple, because these language models are powerful by itself, and you might get the best response without complicating it too much or breaking down the LLM by itself. So I would say the best thing would be to start from there. Yeah.
Do we have any more? One more? Yeah.
I was interested in some of the architecture diagrams that you had in terms of some traditional chat type architectures and kind of transitioning more towards more advanced technologies. And it certainly brings in some implementation challenges in terms of how do you go from an older technology to a new one from an architecture perspective. Any thoughts you have from your experience in that area?
I would actually say slow adoption would span out and gradually replacing it if there is a use case. But I think based on my experience to what I've observed is, of course, these end-to-end architectures are extremely powerful, no doubt on that. And for some use cases, they are really good compared to the conventional architecture where you have your natural language understanding, dialogue state, and then natural language generation. But there is still, even now, there are certain areas where you still want to understand intent and you want to, have like your dialogue state act accordingly. Not everything would have to be replaced by an end-to-end dialogue. So maybe more like a hybrid approach. And when the technology is advanced enough and we feel confident enough to use that end-to-end architecture for an entire assistant by itself, then I would say we can go for it. But right now, I would definitely want to start with a slower hybrid approach and then go towards there. Yeah.
Thank you so much.
Perfect. Thank you.